Hello. In this video I'm going to look at trigonometric equations which look like quadratics. They essentially are quadratic equations, but they're not strictly quadratics because they're trigonometric, but they follow the same rules of quadratics. So for example, this here, if you replace cosine theta with x, you get it's 2x squared minus x minus 1. So a more familiar traditional algebraic quadratic equation. You can solve them exactly the same way if you wish. I don't normally do this, but I do suggest if you want to do it, you can do. Okay, but cosine theta is x, so you write it like this. Then factorise this. That would be your normal approach to solving a quadratic. So 2x and x, that would be 1. You need negative x, so that would be negative 2x plus x. There we go. Most of these factorise. If they don't, you've got to use the formula. Or complete the square, but I recommend formula. Okay, it's rather more awkward, but yeah, they don't always factorise. Okay? Then you get your two solutions. X equals negative half or positive 1, but then that means cosine theta is equal to either one of those. So cosine theta equals negative half, or cosine theta is equal to 1. Okay? And you've got two sets of solutions you've got to find. So you do the inverse cosine of negative a half. Let's just do that. Make sure calculator's in degrees mode. Negative 0.5, 120 degrees. And then your second answer, you subtract from 360 degrees, it gives you 240, so that's that. And then this one, you should know that inverse cosine of 1 is 0, but check it if you wish in your calculator. And then same rule as this, subtract your first answer from 360, get 360. But I'm hoping that you recognise the cosine graph and that here you've got 360 gives you 1 and 0 gives you 1 as well. And just for completeness, the other two solutions, 120, 240. So that's that. Okay, that's your first quadratic. Second, still a quadratic because it's got something squared. But I'll take you through this one as well. Okay, so you don't need to factorise it. You just need to square root both sides. So when you square root both sides, you have sine theta minus 30 degrees. Square root this. Do not forget the plus minus. Remember, when you square root on both sides, you're plus minus. If you forget the plus minus, you're going to lose a chunk of marks because you've got two sets of solutions you've got to find. So I'm going to work this out individually. So first of all, you've got sine theta minus 30 degrees equals positive 1 over root 2. You don't have to worry about rationalising the denominator. It's not that sort of question. Just the final answer is what we're interested in. And we'll solve this one when it's negative 1 over root 2. So inverse sine of 1 over root 2 is 45 degrees. You can work it out in a calculator if you wish. And your second answer, you subtract that from 180. So you get 135 degrees. And let's finish this off. Add 30 to both sides to get final answers. That'll be 75 and 165 degrees. And then back to this one. So here, same again. This one's going to be negative 45. You can check if you wish. So inverse sine of negative 1 over root 2. Sorry, it just came out math error, which is sort of not nice. There we go, try again. Yeah, negative 45. It happens, it just means I typed something in wrong. Or I didn't put a bracket where I was supposed to. That's partly why I prefer doing it in my head, because it's actually quicker. Yeah. But anyway, inverse sine of that, negative 45 degrees. Now, whatever answer you get, you're always subtracting that from 180. So 180 subtract negative 45. You get 225. What we do with these answers, we're going to add on 30 degrees, of course. This one here, though, negative 15. That's not in the required interval, is it? So we're actually going to ignore that one. That one's not going to count. Okay. This one will, though, when we add on 30 degrees. So it's going to be 255 degrees. Will we get another one? Will we get another one? Because normally we expect two answers we've done an interval. Yes, we'll get another one. So the thing to do is, when you've got two initial pairs of answers, keep on adding 360 degrees to generate more. So on the sine graph, you see, it looks something like this. We're solving inverse sine of negative 1 over root 2. So here, you can see your first answer and your second answer. You've got to have two answers. Okay? You've got two answers there. And we've only got one of them so far. So we got the negative one here, but we don't want that, okay? So the answers I've actually got are this one here and this one here. I need that one. So when I've got this one, I can add on 360 degrees to get that one. So we do 360 plus negative 45, and that gives me 315 degrees. Now I'm going to add on 30 to that, so 345 degrees. Okay, and those are my final answers. Make sure you cross out any unwanted answers, because if you leave them there, you might not get full marks. Okay, and to check if you want to do, just substitute. I'm going to do that, the random one. Okay, I'm going to choose that one. Okay, you can always check by substituting back into the original equation. So I'm going to type it out literally as it is. 255 minus 30 degrees. I'm going to do the sine of that, and then I'm going to square it. And the answer I'm hoping to get is a half. Yeah, you get a half. Okay, so you can always do that if you've got time in the exam. Okay, that's something you could do when you finish an exam. Just check your answers by substituting back into the original equation. Okay, one more? Yeah, one more. One of my favourites. I love these. Okay, it's a mixture, isn't it? It's a mixture of sines and cosines. Thing is, it's still a quadratic, so look out for the square terms and the non-square terms. Any constants you have there, quadratics. The thing that makes this challenging is they're not all the same trigonometric functions. So sine, cosine. You've got to change one of them. Okay, how are you going to change that? Well, you've got to make use of this identity here. Let's use x. Sine squared x plus cos squared x is the same as 1. You don't have to write the same as when you're solving equations, just write equals 1 if you wish. And we can just rewrite that so it says either sine squared x equals 1 minus cos squared x by putting this on the other side, or you can write it as cos squared x equals 1 minus sine squared x by putting that one on the other side. You've got to know how to make use of these three results here. Memorise that one, but then use it to get these two. Now, which one are we going to use? Well, we could put the 1 minus sine squared x in there, couldn't we? Or we could put the 1 minus cos squared x in there. But remember our goal here. Our goal is to get the same trigonometric function, either all sines or all cosines. And if we replace that one with 1 minus cos squared x, you've got a sine, a cosine. Okay, so that's not good for us. Whereas if we replace that one there with 1 minus sine squared x, we'll do it. Okay, so I think this is what it says. Yeah. Okay. So if you use this one, so I'm going to rub this off now. I'm just going to stand away in case you need to screenshot that. Okay. We'll use that one, and we're going to write down what we get. So 2, and then 1 minus sine squared x. So I usually recommend you replace the one you're changing with whatever it is in brackets, plus 9 sine x is equal to 3 sine squared x. And then expand the brackets, so you get 2 minus 2 sine squared x plus 9 sine x equals 3 sine squared x. Usual rules of quadratic equations, get everything to one side, make it equal to 0. So let's do that. So put this onto that side. So that'll be 5 sine squared x. And put this into that side as well, minus 9 sine x. And I'm going to put this onto that side as well, subtract 2. Of course, that equals 0. So just check that. So this 5 sine squared x minus 9 sine x minus 2. Okay, all that is equal to 0. I'm just going to write it a little bit neater. Okay, my board doesn't want me to do that. I'll just write it like that. I was hoping to put this on the left hand side, but you can figure out what that means. Okay, so there's our quadratic that we want to solve. Okay, now x has already been used. So whereas in this one, I said look, you can replace this with x, you cannot in this example here. Because if you write 5x squared minus 9x minus 2, it's not the same because x stands for a specific value or set of values, and that's not going to work here. So the general rule is when you replace the trigonometric term, use a different letter. Doesn't matter what letter you use, as long as it's different. So I'll use y. 5y squared minus 9y minus 2 equals 0. Then we can see if it factorises. I'm hoping it will. Most of them do. That's just, as I said earlier, it's a bit annoying if they don't. So I'm going to put the 2 there and the 1 there to get 10 and 1 to make 9. So I need negative 9, so I'd make that negative 10y plus y. Hey, it factorises, which means it's a bit easier. So I've got 5y plus 1, y minus 2 equals 0. Okay, I'm going to make a bit of space, if you don't mind. I'm going to move away, screenshot that if you wish. And then I'm just going to delete that bit there. Well, here we go. Ooh, this board's wonderful. I remember the days when I started off with a blackboard. Could not do that then. Even with what's called a whiteboard, could not do that. It was wonderful when these things sort of came into fashion. So, right, here we go. So from this bracket you've got y equals negative 1/5. And from this bracket you've got y equals 2. Or why am I saying r? Well, we have sine, what was it, x? Yeah, sine x is equal to negative 1/5, or you've got sine x is equal to 2. Got no solution, is it? Okay, because you can't do the inverse sine of 2. Remember the sine graph? Draw it up again. Here we go. So there's 1 there, 2 up there. There's no solution. Okay, that happens sometimes. It's just nicer because it's quicker to answer the question. It means you're not going to get any solutions from that. So you do the inverse sine of this. The inverse sine of negative 1/5. Okay, where is that going to lie? Somewhere here. So I'm expecting to get a negative answer there. So inverse sine of negative 1/5. Bear with me. So negative 11.5. We'll call it negative 11.5 degrees. Radians mode. Right, let's do that again. So angle unit, radians. For this very reason, and I'm sure I've done it in another video somewhere, just keep reading the answer as you're going along. Keep reading the question as you go along. Read them both, make sure they're matching up. Okay, so it needs to be in radians mode. Somewhere here, there's an arrow that says make sure your calculator's in radians mode. Right, I've done that, so I'm going to do it again now. So negative 1/5, inverse sine of that. Going right this time, I'll have what I want. X equals, come on, write for me. X equals negative 0.201, 3 significant figures. Subtract that from pi. So sorry, my phone ran out of space, out of storage, so my video cut towards the end, which is annoying because I nearly got there. So yeah, sorry for the phase into this. But anyway, you'll watch it as a nice seamless video, okay? Because I'm going to edit it together as if, well, almost nothing happened. Right, here we go. So I've got that solution there. So inverse sine of negative 1/5 is that. So to get another answer, you could do that subtracted from pi. So we do pi, subtract that answer. Okay, and we get 3.3. Whoa, no. That's better. 3.34. Does your mind do that sometimes? Does your mind literally go blank? Right? Sometimes mine does. Okay. But then look, the interval's got to be between negative pi and positive pi. That I can see is already not between negative pi and positive pi. So what we want to do is try and find another one. So this is the sine graph, so that's pi to there, and then back to here, that will be negative pi. There's 2 solutions I'm looking for. Both of them are negative, and I've got that one there, which is this. I need somehow to find that one there. Okay. What I'm going to need to do is I'm going to need to take that one I've just got and subtract pi from it. Why is that working? Well, look, can you see the answers I've got so far? If I just use a different highlighter, I've got that one and I've got that one. Those are the answers I've got. Okay? So when I've got my 2 initial answers, I can use those to work out more. If I need to work out further positive answers, I can keep on adding 2 pi to that and get more answers generated for me. But for this answer, I'm going to have to use that one and subtract 2 pi from that to get my required result. So I'm going to do that, subtract 2 pi, subtract 2 pi, and that gives me my next answer that I need, okay, which is going to be negative 2.94. Okay, just checking it's all in radians. Yeah, but my final solution, I'm going to leave like this. I'm going to cross that one out. Remember what I said? I think I've said it before, but if you leave too many answers, if you put answers in that are not within the required interval, you may just get marked down. I mark students how to do that because part of the question should be making sure you're in the interval required. Okay. Right, that's it. That's my few questions on trigonometric equations with quadratics. I'm hoping you found that useful. Thank you for tuning in, and I'll see you again soon.